Hi everyone, Adarsh here from Adarsh Model Train. So today we will see how we can configure light as well as servo based turnout using Jmri and REST API. So for that first we have to go to github.com. So let's go to the GitHub repository. So github.com/adarsh-model-trains into repositories. You can see here Jmri Mqtt Spring Transformer Wireless Ecosystem project. As of now this is a private one, so very soon I am going to make it public so that everybody can use this piece of code. So once we get into this, we'll go to ESP Arduino solutions, and in ESP Arduino solutions we have to go to REST, Servo Turnout and Signals. Once we get into this project, here we can see we have a link to download the source code and how we can do the connection. It's like from node MCU to Uno or node MCU to Omega, you have to use RxTX pin, you have to use common GND, as well as you can pass a 3-volt power supply to power up the node MCU, and then you have to connect PC9685 board, so via SCL and SDA pin from Uno or Mega, and you have to pass external 5-volt power supply. And in this exercise we're gonna use two PC96 board, one for light, one for turnout. So we have to use two PC96 board where we have to pass external power supply to both of the boards, and first board we will be passing SD and SCL line from Uno or Mega, and we will pass 5-volt and GND from Uno or Mega, and then based on our configuration we will configure servo turnout as well as the light on the PC9685 board. So first what we will do, we will just go and download the source code. I'll download it to the desktop. So once code is downloaded, you can see. So in this we have a servo calibration sketch, we have transformer ESP application, and we have Arduino application. So if you go and open the calibration sketch, in the calibration sketch if you go into config.h, you have to select the servo number on the PC96 board. It should be 0 to 15, and board in chain, if you are using multiple board and you want to do the calibration for specific board, a specific servo which is mounted on the specific board, so that board number in the chain you have to put. You can put from 0 to 63 boards, total 64 boards it takes, so 0 to 63 board you can keep. And for the pin number here you can give 0 to 15 pin, and you can just do the servo calibration. Earlier we have done this servo calibration so that we can get the throw and close numbers for the servo. So you can refer if you are following this video tutorial from the start, you must be aware of that already. So first thing what we will do, we will just upload the code to our Arduino and ESP. So now first thing what we will do, we will just open the Arduino sketch here, and we will go to config.h, and in config.h first thing we have to make it signal type anode equal to false, and slow move true. That's up to your choice. If you don't want slow open and close, you can make it false. And just number of turnout board, we need one for servo, one for light, and total number of board we need 2. So we have changed that. And we have open position is 1350 and 1650. So we are using only one board, so we don't need this section. This is for second board, so 0 board, 1 board, 2 board, like that. If you are mounting multiple board for servo, you can do that. And that's it for this. So what we will do is just connect the Uno first, and just go to tools, board type Uno is there, and port number we have to select, that we have selected. Let's compile the code. Code compilation is done, and let's upload the code. So code is uploaded here. In the serial we can see total number of PCA board, turnout board and signal. We have two boards, one board for turnout, one board for light, board number 40 and board number 41. Two boards we are configuring. So we are good with this. You can close this and we'll just open the ESP code. In the ESP code we'll go into config.h. So we have to just give the Wi-Fi username and password, and then node ID we are giving 1 because we are doing for node 1, and then this is the IP address of the machine where our spring transformer application is executing, and this is a port for the application. This is the endpoint and this is the node ID which we are passing. So we are good with this. So we have to change first the board type to node MCU, and port we have to change. So what we will do, we will just connect the connect the tool port here to 10, and now we can just compile the code. Code compilation is done, and let's upload the code. It usually takes some time to upload the code. So now code is uploaded, and let's open the serial monitor. It's connected to Wi-Fi but not able to connect to the server. So error, server is not reachable because we have not started the spring transformer application, and it will every 1 minute it will keep pinging to the server, and every time it will get the message that server is not reachable. So we are good with that as of now. So let's close this one. So we are done with the uploading of the code. We can close this, and so next step what we have to do, we have to just start we have to do the configuration of PC96 board, everything. Or first once we are done with the configuration, we will just start the MQTT and spring transformer application and validate our configuration, and then we'll test the whole configuration with the Jmri panel pro. So here now you can see I have done the configuration here with all the boards. So here first thing you will see, this is a node MCU. From node MCU, this red one and ground one. Red one is 3 volt VCC which is coming from Arduino, and ground one is a GND. White one is a RX and black one is a TX which is going opposite here. So RX from here will go to TX from here, and TX from here will go to RX from here. That is one configuration. That is from Uno to Arduino to node MCU. And this is yellow one and orange one is a SD and SCL line, and this brown and red one is a 5 volt and GND, VCC and GND, which is going to the board number 1 here for GND, VCC and SD and SCL line. And then board number 2 is snapped to the back side of the first board. And if you see here, from this is external 5 volt power supply which is going to second board as well as the first board. White one is a VCC and blue one is a GND wire. And from the end of the second board, you can see there is a 5 volt VCC and GND is coming to this breadboard. So in this breadboard you can see there is a blue and orange wire which is going to this relay switch, to power up this relay switch. And there's from the second board, pin number 0, the orange wire is coming to the relay switch to control on and off position of the relay switch. And here you can see from board number 0, pin number 0, there's a servo connection going to the servo, which is to control this throw and close position of the servo. And here if you see again, if you come back to this breadboard, this black wire is carrying 5 volt to the center pin of the relay switch, and this white one is taking the connection. When the relay switch is on, it will power up this LED on this side. And so here you can see this white one, when relay switch is on, this will carry a power here, and there's a resistor mounted here to protect it from blowing it. And there's a LED which represents the light here. So the long leg of LED is towards the resistor side, and short leg is on the breadboard towards the common Jmri side on the board. So this is how the configuration is. And now what we will do is we'll just start the MQTT as well as Spring Transformer application and validate our configuration first. And after validation of configuration, we'll open the Panel Pro and we'll test our configuration. So now what we will do is we'll start the MQTT first, and then we'll start the Spring Transformer application. So let's open the terminal. Desktop, MQTT config, Python start. So our application MQTT is started, and then we will start the MQTT client, mqttx.app. So here you can see, let's clear up the history. So we don't need for node 2 as of now. So okay, let's connect the client. So it's connected here, and we don't need node 2, we need only for node 1. So we have already I have created a separate video just for this client, how we can use the client, install the client and all. So please refer to that video, it's a part of this video series. So first what we will do, we'll just go to the Spring Transformer application here. We'll go to Spring Jmri MQTT data transformer. You can download the jar file as well as the configuration file from here, and you can use this command. I have explained everything separately in the earlier video tutorial. So after this, what we have to do is we'll just open one more tab here, cd Spring MQTT. Okay, but before that, let's check the configuration in the YAML file. Don't need this. So node number 1, enable node is enabled, publishing to MQTT is enabled, REST API is enabled, light count is 1, 2 LED signal count we don't need, 3 LED signal count is 0, that's fine. Servo Turnout count is 1, Snap Turnout count is 0, and light board is 1, and servo turnout board is 1. That's what we need. So we are good with the configuration here. We can close this, and we can close this also, and we can paste the command, so which will start our application, transformer application started. Now we'll just validate we'll just go down to this readme page, and here we have a command to get a for specific node. So we'll just copy this URL and paste this. We just want to validate node number 1, node is enabled, publishing to MQTT is enabled, REST API is enabled, light start with address start with 10,000, light count is 1, 2 LED count 0, 3 LED count 0, servo turnout count is 1 starting from 40,000 address, Light turnout board is 1, light board is 1, that's okay. Total number of board servo board required is 1, total number of snap turnout board required is 0, total number of light and signal board is required is 1. Servo number 1 on Jmri address 40001 on board number, pin number, status. So board number 0, pin number 0, throw signal. Board number 0, pin number 0, close signal. So if you see here closely, this is the board number 0, pin number 0, throw and close for the servo will be here only. And if you see here, light number 1, Jmri address 10,000, board number, pin number, status. So board number 1, pin number 0 on status, board number 1, pin number 0 off status. So board number, this is 0, this is 1. So board number 1, pin number 0, it's for on and off of the light here. Board number 1, pin number 0, PWM pin, basically we have to use PWM pin, which is a yellow because it contains yellow, red and black. So yellow is a PWM pin, so we have to use PWM pin here. So we are good with our configuration also. So now what we can do, we can just minimize this part, we don't need that. You can just move little bit up here, and then we can start the panel pro. So if panel pro is started, so Jmri panel pro is started, and here we can see everything is created. So first thing what we have to do, we have to ensure that we are on the right network. So let's change the network here, and because it doesn't have internet, this will pop up always. And we'll go to tool, table, turnout. We'll open the light first. So light is configured on 10,001, and turnout we have configured already on 40,001. So let's test the light first, but before that we have to connect the I have to start everything here. So let's monitor the logs also. What logs are coming? I'll just monitor that log. Change the board number, port number. So it's connected. So this is what the log message is on the server, not on the server, on our Arduino. So if I just refresh this here, so connected to Wi-Fi. Yeah, so here we can see there is no data available for this node as of now, because we have not published anything, we have not done anything, so its data is not there in the queue. So now what we'll do, we'll just test the light first. So light is already on the on state, let's make it off. So here we can see this is what we are getting, the message, and this is what the message we are getting in the queue, topic, Mqtt topic, and this is what we are getting in the Arduino. You can just make it on. So here you can see this one off, on, so it's working. And we'll go to, I'll just show you in the bigger screen here. So it's off, and now it's on. So that is done, and then we'll test the turnout here. So once we go to turnout, snap turnout 40,001 here, it's in close position. So it's in close position as of now, so train can go straight. Let's throw it. So you can see here it's moving. Again I am just throwing it. So it's a slow one. I'll just make it zoom, bigger screen here. Turnout is thrown and turnout is closed there. That section thrown, close. So, and if you see here in the desktop what messages we are getting on this. So this, if you see this one, this is the train tracks Jmri what is pushing, and if you see this black line, this is the black one what our node is getting. So here you can see train track turnout 40,001 EMT node 1 data 40,001 0 board 0 pin close. And if I just make it open here, train track turnout 40,001 thrown 40,001 0 0 throw. And if we go to light, so for the light, if you see train track light 10,001 off, AMT and node 1 data 10,001 first board 0th pin off, and first board 0th pin on. So this is how we can do the testing. And here you can see all the messages which we can see on the Arduino console, serial console basically. So this is for this video, and stay tuned for upcoming content, because in next things gonna be more excited, where we will configure turnout signals and light together. And signals can be 2 LED signal, 3 LED signal, like 2 LED is red and green and 3 LED is red, yellow, green. And then once we are done, we'll just do everything together. And once this is done, then we'll go to the block detection using IR sensor as well as CT sensors. So stay tuned for upcoming content, and please subscribe to my channel. Thank you.